Lesson 3. Welcome to yet another episode or another video on cyclic geometry, whereby in this lesson we are going to explore, or rather we are going to calculate or rather find the angle that is subtended by a diameter. Now here is the theorem. It's our second theorem. Just a recap. Our first theorem was saying the angle at the center is always twice the angle on the circumference. So, and then in this video we are going to find the value of the angle subtended by the diameter. So here's the theorem. It says the angle subtended by the diameter is always 90 degrees. Let's state this theorem. Is the main idea whenever a triangle is drawn using a diameter of a circle, the angle opposite to the diameter is always 90 degrees. Now, where is this 90 degrees actually appearing? Let's just assume something here. Let's just assume you are having a large dome shape, and then you are standing somewhere, anywhere, in fact, on that shape. Let's say you are standing here, and then you are looking at both ends of the diameter of the dome, at both ends of the dome like that. This is your diameter now. So what are we saying? We are saying if you are standing at this point here, the angle that's going to be made in your eyes when you look at both the ends here, it's always going to be a 90 degrees, this one here, irrespective of where you are standing on the circumference of the dome shape. Now let's go to GeoGebra to view this theorem. Now here is our GeoGebra. I've already drawn a diameter here, which is GF, and then the center is E. So if you are standing anywhere on the circumference and you are looking at both ends of the diameter, you are looking at both G and F, the angle at your eyes is going to be 90 degrees, which is this angle here, I to J, angle G I F. It's always going to be 90 degrees. Let's just measure this one. As you can see, that's 90 degrees, irrespective of where you are standing. You might be standing here, still 90 degrees. You might be standing there, still 90 degrees. You might be standing there, wherever you are, it's still going to be 90 degrees, 90 degrees, 90 degrees, 90 degrees, anywhere on the circumference. If you are looking at both ends of the diameter, the angle subtended is going to be 90 degrees. Now let's look at why is this actually happening. Why is this actually happening? Maybe let's just present some kind of a proof to this theorem. Let me just join. Standing anywhere from here, and then from there to there. Now we are first going to use the theory, our theorem 1, which says the angle at the center is twice the angle on the circumference. Now this is our center, and then the angle here it's 180 degrees. That's a straight angle. It's 180 degrees. You want to find the value of the angle at this point here. Let's call it X. Let's call this one X. So how do we find that angle? So the theorem is saying angle at center is equals to 2 multiplied by angle at circumference. What is our angle at the center? The angle at the center in our case is 180 degrees. And then we know that is equals to 2 times the angle at the circumference. What's the angle at the circumference? It's x. Now let's solve for x from that equation. We are going to divide both sides by 2 so that we can isolate x over 2 over 2. And then on your right, the 2's are going to cancel out. And then you will be left with x is equals to 180 divided by 2. It's nothing but 90 degrees, which means our theorem angle at the center being twice the angle on the circumference, it's proving for us that this angle here is actually 90 degrees, because the angle at the center is 180 and then the angle on the circumference should be half of that, so that's 90 degrees. So let's try to use another theorem. Another way to prove, let's first draw the circle. I won't be able to draw a perfect circle in this case. Please don't judge me. Now, this is the diameter. Now, let's just throw this stuff randomly here. Something like that. We want to ascertain, to calculate this angle here. Maybe let's just draw a line here. Going to the center. Maybe that's the center there. Now let's just say this angle is 60 degrees. Let's just say this angle is 60 degrees. And then the angle on the other side, since both of these angles should give us 180, we are expecting it to be 120 degrees. Now, since this is one circle, so all radiuses in one circle, all radii thrown in the same circle, should have an equal length. What does that tell us? This is telling us that this length here is equals to this, since they are both the radii. And even this one is a radii. All of them, they are radius. So they must have an equal length. What does this tell us? It tells us that this triangle here is actually an isosceles triangle. Even this one here is actually an isosceles triangle, which means that the angle, the base angle of this isosceles triangle, we can call it x, call this one 2x. Then let's calculate the value of x. X plus 60 should give us 180. Sum of angles in a triangle. Sum of angles in a triangle. Now, this is 2x plus 60 is equals to 180. Now, let's do the needful. What does the needful say? Let's subtract 60 on both sides of the equation, minus 60 this side, and then the side is also subtract 60, so that this 60 here will cancel this one. And then on your left hand side, you are left with 2x being equals to 180 minus 60, that's 120. Then let's also do the needful. Divide both sides by the coefficient of x, which is 2. So if we divide both sides by 2, what is going to happen here is this 2 is going to cancel this one, so that on the left hand side you are left with x is equals to 60, which means the value of this one is 60 degrees. 60 degrees. Now same applies to this other triangle here. Let me try to highlight it in red, this triangle here. The triangle highlighted in red is also an isosceles triangle. If that's an isosceles triangle, this is also telling us that this angle here, the base angles y, they are equal. Now let's calculate the value of y. Y plus 120 should give me 180, sum of interior angles in a triangle. So y plus y, it's 2y plus 120. This is going to give us the 180 there. Now from there, let's subtract the 120 on both sides. Minus 120 minus 120. So that this one is going to cancel this. And then on your left, you are left with 2y, which is equals to 180 minus 120, sorry. That should be giving me 60 degrees. Then from there, divide both sides by the coefficient of y, which is 2. Dividing both sides by 2. What's happening? These 2 is going to be cancelled out by that one there, so that the value of y is equals to 60 divided by 2, giving me 30 degrees, which simply tells us that this is 30 degrees and this is 30 degrees. But let's check something here real quick. This angle here, we are looking for this one. This angle here, the part of it is 60 degrees and then the other part of it is 30. So if we combine the two, we are going to get its value. So the value of the angle there, it's going to be, the value is 60 plus 30 degrees, which should give me 90 degrees. So the angle subtended by the diameter is always equals to, it's always equals to 90 degrees. I hope that was clear. Now let's take 2 examples so that we can conceptualize this concept even more. First example. In the diagram, A, B, C are points on the circumference of a circle, and the line AB is the diameter. Find the values of x and y. For the fact that they've told us that this line AB is a diameter, this angle must be this angle x must be 90 degrees. You don't even need to argue that x is 90 degrees. There is it. That's an angle in a semicircle. Angle in a semicircle. or simply angle subtended by the diameter. Then from there, to find the value of y, we are going to use sum of angles in a triangle. So 46 plus x, which is 90, plus y should give us 180. And then 46 plus 90, that is giving me 136 plus y. This is equals to 180 degrees. Then let's subtract 136 from both sides of the equation. Minus 136 minus 136. Then this one, it's going to be cancelled out by this, because they have different signs here, as you can see. So they give us 0, so that on the left we are left with y. Being equals to 180 minus 136, that's giving me a 44 degrees. And that's it for the first example. So the trick here was you identifying that this is a diameter, so this is 90. If they tell you that this is 90, then therefore this one is diameter. Now there is another question. Two chords A, B, and BC connects to the end of a diameter AC. Chord AB is equals to 4 and chord BC is equals to 3. Calculate the length of the diameter. Let's try to sketch this thing so that everything is clear in our eyes what's actually happening here. I've tried. Try to get it right now. That's my diameter. And then there is the point C up there. Now let's put in the given labels. AB is a chord, so this should be A. This should be B. And BC is also a chord. Then AC is our diameter there. Then AB, this is 4. This is 3. And then you are required to find AC. How do you find that side without knowing even a single angle in the circle? But now let's go to the question. It said AC is a diameter. So if this is a diameter, this should be 90 degrees. That's the trick. So once this is 90 degrees, then you are having a right angle triangle. You want a that side, you are given two sides. You can use what? The Pythagorean theorem. Let's use the Pythagorean theorem. It says the hypotenuse squared. Our hypotenuse in this case is AC. So our AC squared is equals to the sum of the other two sides square, which is 4 squared plus 3 squared. Then our AC is going to be equals to 4 squared, that's 16, 3 squared, that's 9. Then your AC squared is equals to 16 plus 9, that's 25. Then taking the square root on both sides, you are going to get that your AC is actually equals to 5 units. So the diameter is actually 5 units. We just took the square root to that side. Thank you for staying tuned for this video. What we've learned is that the angle in a semicircle is 90 degrees, or rather the angle subtended by the diameter on the circumference is 90 degrees.